Lesson 11.6, Recursion and Special Sequences. Now, in talking about this, we need to understand something important, and that is that you can have a list of a lot of different numbers generated in many different ways, and they aren't always as simple as saying I'm going to add 3 every time to get the next one in the list. There's many different ways, many formulas, algorithms, codes, whatever you want to do to generate a list of numbers. So it's very important to understand this idea of positioning. If I give you a sub n, which is some number on a list, the next number based on position would be a sub n plus 1. That's the number to the right of a sub n, no matter where that is. The next number would be a sub n plus 2, etc. If I go the other direction, it would be a sub n minus 1. And if I go further away from n, a sub n, it would be a sub n minus 2. So again, if I have like a sub 8, then this one would be a sub 9, and then a sub 10, etc. And this would be a sub 7, a sub 6, etc. So the notation is important to understand for us to proceed. Again, this represents where you are, this represents 1 more to the right of it, or 1 greater than it, and this would be 1 less than it. So, to generate a list, let's talk about a famous one for a moment. Fibonacci has a list of numbers, and his algorithm for creating the next number in the list is to say, I'm going to start with this number, and my algorithm is I'm going to add that number to the one before it. Well, there's nothing there, so it goes to 1. Algorithm says take that number, add it to the one before it. That's our 2. To get the next number, we take 2, add it to the one before it, and we get 3. Add it to the one before it, and you get 5. Add it to the one before, you get 8. Add it to the one before, you get 13. So, with that algorithm, the next one would be 13 plus 8, so 21. And you would continue that algorithm. And that's just a quick little joke there. I won't worry about that one. So what is the recursive formula for that? What is the algorithm that we just stated? Well, if you use the notation that we discussed right here, above in the top, if you understand that notation, then Fibonacci would say, I'm going to find a number by taking the 2 numbers to the left of it, of a sub n, and adding them together. Okay, so this number would be found by taking this number plus this number, and so on. And you can have many different types of algorithms, but some key things are to understand that to be able to use a recursive formula, you must be given the first term to start the sequence, and then the formula to generate the rest of it. So here we have an example, and it tells us that our first term is 5. And here it tells us what the algorithm is. Now look at your lettering here. If you have a sub n, you're going to take it times 2 and add 7 to get the next one. That's the next one to the right. So that term is found by taking the number previous to it, times it by 2, and add 7. And we have this little rule here that n has to be greater than or equal to 1. Okay? So if we start with 5, the algorithm says, okay, so this is a sub 1. You're going to take it times 2, which gives you 10, and add 7, and you get 17. So in other words, a sub 1 times 2 plus 7 will give you a sub, now remember, a sub 1, so this n is a 1. 1 plus 1 will give you the second term. So the next one would be 17 times 2, 34, plus 7, 34, 41. Next one, 41 times 2, 82, plus 7, 89. And the next one would be 185. Going to take a little bit of practice with that, so getting to understand the notation, but the idea is starting with one number right here, using this rule to give you the next term. In functional notation, it looks like this. They would call it iterates, to iterate or to redo, to go over and over again. And that's what you do to create the next number in the list. Find the first 3 iterates. If you have x of 0, meaning that's your first term, now they start at 0. To find the next one, they ask you to do this algorithm. I want you to take it times 3 and subtract 1. So plug a 5 in and you get 5 times 3. Subtract 1 and we get 14. Okay, if you plug the next number in, which is 14, you get 3 times 14 minus 1, which is 41. Then 3 times 41 minus 1 gives us 122. And those are the first 3 iterates if we start with 5 and have this algorithm. And this ends lesson 11.6.